Hello all and welcome to today's tutorial. We are into week 4 now of the course Introduction to Statistics. Okay, so I am Amir and I'll be taking you through this tutorial. Before we begin, any questions from the previous tutorial? I could not resolve, we do that, I could not resolve the question on movements. I tried that, but I didn't know any way around like anyone to respond even. So I'm sorry, I can't help you with that. I didn't understand the question, what it meant. The question was how many movements are there about the mean given you have 4 movements already. So I didn't get that. But if there are any other doubts, you can ask me now. Looks like the strength of the class is decreased. It's gone down to 8. Also, I had problems regarding the previous class while we did the class. So because I ran out of space on my computer, but I did upload another video in which we covered everything that we did in the class. Yeah. Everyone is able to access the videos and the content from my side. Can I hear a yes or a no? The class seems to be quiet. Okay, great, Siddharth. Thanks. So it'll be great if you can speak up because when I shift to my presentation mode, I can't see any text that comes up as messages. Okay. So okay, since no one has doubts regarding the previous content covered in the tutorials, let's dive into what we have for this week. So this week you covered basically some basics of probability distributions, different kinds of probability distributions, and you did conditional probability also. I just hinted at it in the previous tutorial, but in this week you did cover it in some detail. So, and I realized that most of your assignment is based on that conditional probability. So, we'll do a couple of questions on conditional probability and just cover other content that is there. Also, there were things like moments. We had expectation, variance, covariance. We've already covered that in our previous lectures. Okay, we did that for a Gaussian. I would encourage you to look up the internet and see what the various moments are for different kinds of distributions. For example, Poisson, binomial, Bernoulli, and things like that. The derivation is beyond the scope of this course, so we won't get into how these moments are derived. Okay. Okay. One second. I'll share my screen. Okay. So in this week you did probability distribution. Before that, can someone tell me what you understand by a random variable? You must have come across this term. It's very important. What do you mean by random variable? Yeah? Anyone? Can you just tell me in plain word what do you mean by random variable? Because your entire week's content was based on this one quantity that is called random variable. We have already done this in our previous class. We hinted at this. For example, if you toss a coin, you give rise to random variables. What is it?
Either one event or the other event.
Okay, let me guide you through it. So when we tossed a coin, there were two possible outcomes, right? Head and tail. Now, when we do mathematics and probability, we can't write these things as head or tail, but we need to formalize this and make these things measurable, that is, quantify this. What I mean by this is you need to represent your head and tail on a number line. Okay. Now, when you do that, when you represent or map your events in a sample space to that on a number line, they become a random variable. Okay. So random variable is nothing but it is a function. Okay. that takes your possible outcomes in a sample space, for example, head or a tail, to a measurable space. For example, you can represent head as 0 and tail as 1. Okay, and now you have come to the space of real numbers. Okay, you can represent your head and tail on a number line. When you do that, your head and tail become random variables. Okay, now the next thing is you came across something called as probability distribution and probability mass functions. Now there's a difference between these two. Probability distribution functions are applies only to continuous random variables. Okay. Now what do we encounter continuous variables in our daily life? Do we? Can someone and give us their thoughts on this? Do we see continuous variables around us? Yeah. If it's too quiet, then we won't have fun in the class.
Height, weight.
Anyone?
Height, weight comes under continuous variable.
Arun Kumar wanted to speak, but I can't hear you.
Height and weight, sir.
Is it my mic? Oh, phone was on. Sorry. Yes. Yes, Arun Kumar.
Height and weight comes under continuous variable.
Sorry.
Height and weight.
Are they continuous?
They keeps on changing. They can't.
So yeah. So the whole reason, one of the reasons we do statistics, okay, is to make these things continuous. So height and weight are actually by nature continuous. Yes, you are right. But when we measure them, when we take a ruler and measure them, we discretize them. Okay.
Yes.
So all measurements that we make, all measurements, to an extent, you can have something. You can have a scale which has like microns in it, like you can measure up to the level of microns or even nanometers. But then that's it. You'll have to end somewhere, right? Okay, so you get discrete. Any measurement you make is a discretization of whatever quantity you are measuring. For example, height. When I measure 1.82 meters, it's 1.82 meters, not 1.82 something 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 something, because we can't measure with that precision. Okay, I would encourage all of you to go read up on significant figures. Okay, and that has direct bearings on probability distribution functions. Okay, but just to let you know, continuous variables, we don't see them around us. We see them around us, but the moment we measure them, they become discrete. Okay. However, these probability distribution functions are important to do statistics. We approximate things. For example, when we measure stuff, we assume that they are Gaussian, they are normal, and things like that. These are approximations we make because it becomes easier to stay within the realm of probability distribution functions. Okay, things become easier to calculate and things like that. Okay, that's why probability distributions are helpful. Okay, a variant of probability distribution function is probability mass functions, which we actually see around us. Okay, these are for discrete variables. Okay, but for all practical purposes, we sort of assume PMFs to be PDFs and make our calculations. For example, when we calculate our standard deviations and things like that, we assume that these are continuous. Okay, and it becomes easy. If you see, if you actually go into all these derivations, it becomes easy for us to assume that a random variable is continuous. Okay, so here are some examples. For example, here you have a uniform distribution function. What it basically is f of x is your PDF, and it's constant between say two values, okay, a and b. Can you tell me physical processes where we have uniform distributions? We have already done this. I just spoke about this. Where can we see uniform distributions in what kind of processes? Or give me an example of a process. Toss of a coin, right? For example, if you had this space going from 0 to 1, where 0 being head and 1 being tail, then it would have a constant probability of 1 by 2. 1 by b minus a would be 1 by whatever, 1 minus 0, or we could have a as minus 1 here, and we could take a magnitude of that 1 by 2, right? Toss of a coin is a uniform has a uniform random distribution. Both head and tail are 1 by 2. Next, we have something known as normal distribution. where you have this kind of shape. We have already done this, where the mean, median, and mode are similar, and we have a standard deviation. And this entire distribution can be characterized, or can be like, you can get this entire distribution just by its mean and standard deviation. Okay, and then you have the binomial distribution, which comes from your Bernoulli trials. Okay, and then you have a limitation of your binomial distribution. We won't get into this, but when you have a limitation of binomial distribution, that is when your n is very large and your n into p, that is p is your probability of some event occurring, is constant, then you get Poisson distributions. Okay, all these distributions have their own uses. For example, Poisson distributions are useful when we have to calculate number of events that occur within a given time interval. What is the probability of 5 events occurring within a given time interval, or something like that? Okay, most useful is this normal distribution, because it turns out that when you sort of measure a lot of things and plot the random thing, plot the random frequency of the random variable, they tend to show normal distribution. This is very empirical. Somehow nature seems to distribute itself in a normal way. Okay, and there's no mathematical proof, not proof, but no reason for that. But most physical processes follow a normal distribution, which is why it's so important. Next, we come to conditional probability, which sort of basically forms the core of this week's content. And we did touch upon this in our previous class. I'll just go over it again. For example, if you are given two sets, okay, two sets of events that can occur. Set is A and set A and set B. What is the probability of an event in set A occurring given your set B? Okay, it's nothing but P of A intersection B divided by probability of B. Okay, and this is just this formula. It's called the Bayes theorem. Okay, it basically says that what is the probability that events in A occur given that events in B have already occurred. Okay, so given that events in B have occurred, what is the probability of getting events in E? Okay, let's do an example for that, and we'll just do a couple, because you'll get the gist of how it's done. Okay, now suppose you're given a table like this, wherein you have boys and girls going to school. Okay, they go to school, and they can go through either in any of these three ways. They can go by car, that is their parents drop them, by foot, or by bicycle. Okay, now given this table, you are asked to calculate the probability of boys going to school by car. How would you do this? Anyone? No, don't look at how I've done this, but anyone, can you tell me, since you have done the week's classes, how would you go about doing this? What is the probability of boys going to school by car given this set? So you need to calculate the probability that, given that you have boys only, what is the probability they go by car, right? So you have to calculate this probability of car given you have only boys. Okay, it's nothing but probability of intersection of car into boys, that is intersection of the probability of car and boys, divided by probability of your students only being boys. Okay, so did you get this? This is important. This Once you know this, you can calculate the rest. Okay, you need to calculate probability of car, boys going in car, so intersection of the probability of car and boys divided by the probability that you have boys only. Okay, now the probability of car into boys is given by this thing, this cell. So 200 boys go by car. Okay, but what's the probability of that? So you need to divide 200 divided by the total number of boys and girls. Okay, that is, or you need to sum this over all students going by car, foot, and bicycle. If you sum all of these quantities, you get 1300. So it's 200 divided by 1300. Now, what is the probability that you have only boys? Okay, you need to calculate the number of boys. If you sum this over 200 plus 330 plus 120, you get 650. 650 divided by total number of boys and girls. Again, that's 1300 if you sum all of these boys and girls together. Okay. Now, probability of car given boys is nothing but this, right? So if you substitute these values that we have gotten into this equation, you'll get 200 divided by 650, and that's 0.31. So that is the probability of boys going to school by car. Okay? Did everyone get this example? Because this all conditional probability examples are like this. Okay, there's no variation. You'll have a 2 cross 3 table or 3 cross 2 table or something. You'll be given this data in words and you'll have to do it. Okay. Anyone? Anyone have questions or doubts regarding what we just did? It's important. Okay. Try to understand what it means. Okay, let's do another example. Okay. So again, you're given a table like this. This is the table of candidates. Okay, you just go to some club and you enroll into swimming, climbing, or rappelling. And this is a table showing how many of them do any of these swimming, climbing, and rappelling, and whether they are over 14 or under 14. Okay. Now you need to calculate what is the probability of a candidate undertaking rappelling, okay, given that he or she is over 14 years of age. Okay, the same thing. You need to calculate probability of rappelling given that they are over 14, and that's given by probability of rappelling intersection that they are over 14. So probability that they choose rappelling and that they are over 14 divided by the probability that they are over 14. Okay. Now, probability that they choose rappelling and are over 14 is this. It's 24. You see, they are rappelling and they are over 14. It's 24 divided by the total number of candidates that choose either climbing or swimming or rappelling. Okay. So if you sum this, you get 121. Okay. So it's 24 by 121. Probability that they are over 14. So you need to sum this up. 18 plus 32 plus 24. That is 74. Okay. 74 divided by the total number, that is whether they are over 14 or under 14, that's 121. Now probability that they are rappelling and over 14, given they are over 14, is basically you need to substitute these values into this equation. So it's 24 divided by 74, 121 and 121 cancel out. So 24 by 74 is 0.32. Yeah.
So that asterisk is the intersection or something.
Yes, intersection is this, right? Probability that they choose rappelling and they are over 14. So that's 24. 24 is the number of students. You need to calculate the probability of that intersection occurring. So it's 24 divided by the total number of individuals that choose either swimming, climbing, or rappelling. If you can, so one thing is in all these tables, if you sum the columns, okay, and then calculate the sum of that, that will be equal to the sum of both these rows, both these rows, both these rows. If you sum these over like this, if you sum like this, and like this, and add them over, that will be equal to whatever sums you get here by adding these columns. Okay, so it will be 121 and 121. It has to be. Okay, and intersection is just this. So you need to calculate the probability of intersection. I mean, I've represented intersection as a multiplication mark. I don't have that in a symbol. I don't know where it is on PowerPoint, but yeah. So it's 24 divided by the total number of individuals. Did you get this?
Yes, sir.
Even in the previous thing, we calculate intersection of car and boys. So car and boys is 200 divided by probability, that is divided by 1300. That is sum of all individuals who are traveling by car, foot, and bicycle. That's 1000. Okay. They cancel out, but that's how you calculate probability. They cancel out in this last equation, but this is how you actually do it. You step by step. Okay. So these two questions sort of cover your conditional probability in some sense. Okay? And most questions in your assignment are based on this. One other thing that I saw in your thing was permutation and combinations. How many different ways can you do certain things and like that. We'll do one question based on that, but I implore you to go and read up more. This is important to why is permutation combination important? It's because it allows you to calculate all number of possible events. Okay, in your when you're calculating probability. For example, if I ask you a question, given I toss a head three times, given I toss a coin three times, what are the how many ways in which are there? Okay, let me put this in another manner. Okay, given I toss a coin three times, what is the probability that I get head at least once? Yeah, and to do this, you need to know permutation combination. Okay, I won't tell you why, it's there in your assignment, but you need to, and also you'll need to use the Bernoulli's theorem to do this. Okay, Bernoulli probability, Bernoulli-Drells probability to do this. If you have questions, you can ask me now. Maybe I can solve one of them, and uh, you might have an idea. But otherwise, we'll do another question just based on permutation. So there is a word called apple, and the question is, in how many ways can this entire word be rearranged? Okay, so this is nothing but how many letters do you have? You have 5 letters. It's 5 factorial divided by 2 factorial. Why 2 factorial? Because p is repeated 2 times. Okay, these are simple ways, and to do this, we need to be practice quite a bit on permutations, combinations, and you will know why I have written 5 factorial by 2 factorial. Okay, but this is one way to do this. Let's do one more example since I actually hinted at it. Okay, so question: given you toss a coin three times, what is the probability that you get head at least once? Okay. Now, if you see, no, your your events of interest are these. Okay, you can get head with the first time you toss it, or you can get heads the second time you toss the coin, or oh sorry, oh sorry, what am I doing? And you can get, so when you toss a coin three times, and what is the probability that you get head at least once? You can get it in these three possible ways, right? You can get head in the first instance, or a head in the second instance, or a head in the third instance. Now you need to calculate the probability of this happening. So that is nothing but probability of this happening is nothing but 1 by 8 plus 1 by 8 plus 1 by 8. Why am I doing this? Why am I doing 1 by 8? Because for this alone to happen, head probability of getting head in the first instance is 1 by 2, and the other two things not getting that is 1 by 2 into 1 by 2. So 1 by 2 into 1 by 2 into 1 by 2 is 1 by 8. Did everyone get this? Yeah?
Yes, sir.
Yeah. And now why I'm adding this is because you can get this or this or this. Now the word or is important. Okay. In the first instance, I've got 1 by 8 because I've used an AND operator. I need to get the first head and then tails for the next two things. So that's why I've multiplied 1 by 2 three times. Okay. But when I want something like this, I have to do 1 by 8 plus 1 by 8 plus 1 by 8, and that is nothing but 3 by 8. Okay. Okay, so this is, that's why I'm doing a addition. I need to get an or, either this event or this event or this event. Whenever I do an or, I add my probabilities. When I do an and, when I need everything happening simultaneously, I do a multiplication. So this problem kind of has both things going on, and for these individual instances and or between these kind of things will come up when you do Bernoulli trials and things like that. For example, if the question is, maybe I won't do this now, but given I toss a coin 10 times, what is the probability that I get head 4 times? Okay, this is a straight problem from Bernoulli distributions. Okay, I implore you to go do this. Okay, because these kind of questions are important. That I get ahead exactly 4 times. Okay, and this is different from say this. So go to both these variants, get at least 4 times, and see how they are different. Okay, you once you work out these examples, you'll get a feel for how, all these things. Head exactly 4 times and at least 4 times. Okay, you will get different probabilities, and you will see why they are different and things like that. Okay, so these are just basic probability things that have to do permutation, and that have to do with permutation and combination. Okay, so I don't have anything more to do in this tutorial, unless you guys want me to do something which is not very directly related to your assignment. Okay, because I don't want to solve those questions in the assignment. But if there's something else that is that you have not understood in the lectures or something, you can ask.
Okay. I just want to ask one question. I'm Sadhna.
Yeah.
And
Yes, you can introduce yourself, Sadhna. What do you do? And
okay, so I'm a professor at ICT, Institute of Chemical Technology. I'm a pharmacologist.
okay.
So I did this course because I was interested in doing biostatistics, but somehow I'm getting confused with correlation coefficient and those equations.
Okay.
So okay, so I'll just tell you, I was just doing the assignment
Okay.
number 3,
Okay.
and as rho is the correlation coefficient,
Yes.
right?
Yes. Yes.
And then it is defined as one second. Meaning
Between x and y
I
divided
just
by.
got so confused that I stopped doing the pardon.
It is the ratio of the covariance between two variables like a and b divided by the
Correct.
product
It
of the
is
stack deviation.
SXY
Yeah.
upon S
Sigma
X
x into sigma y.
SY. Sigma x and sigma. So SXY is again given by the expression summation of xi bar into yi bar
Into
divided by n upon 1, n minus 1,
Yeah.
right?
It is a summation of xi minus x bar into yi minus y bar divided by n minus 1.
Correct.
Yes.
Now I just want to know what is. Please explain me those equations. Y is equal to. See, I've always studied y.
Okay. Maybe we'll do the. I'll go to that lecture.
Y is equal to. So I do not understand. Yeah.
Yeah. Yeah.
I'm so confused that I just stopped doing it.
We did that in the last lecture. I'll do it again. So okay, first let's calculate covariance. Okay, now you are given a table like this, right? Okay, you have a x and a y value, x value, y value, x value, y value. Okay, so these are your x's and these are your corresponding y's. Now covariance is given by sigma x minus xi, where where capital X is your mean of your xi's. Okay, it's the mean of all these x values. So if you take the mean of 165,
Capital X minus XY. Okay, 1 minute, 1 minute.
so this is your
Can you
capital
just go
mean.
back to that slide you showed just?
Yeah. So this is your capital X.
So this is what we call as SXY, right?
No. This is not SS. This entire
Summation
term
of-
is SXY.
Correct. The whole thing is SXY.
Yeah.
So it is X bar minus XI,
Yeah.
or it is XI minus X bar.
So you can write it either ways. Yeah. So the problem here will happen if you write x minus xi and then yi minus y bar. Okay. You have to be consistent. Okay. If you write x minus
Okay,
xi
understood. Yeah.
into y minus yi, it's equivalent to writing xi minus x bar into yi minus y bar. But don't interchange. Don't write x minus xi
Okay.
into yi minus y. That is different.
Okay.
Okay, because then you are
Okay, so
making a
this I
mistake.
understood.
Yeah.
So covariance is okay, I got it. Now you tell me about those equations.
So once you calculate so x minus xi, so you need to add all of this. Okay, x minus xi, that's the first set of values for x and y. Xi and
So
y
is
is
it
165 and 1.
I used to do y is equal to mx plus.
Sorry, I didn't get you.
That I'll do. But sounds next. So is it a
Sorry, your voice is breaking and I could not get what you
hello?
said.
Okay. So I just wanted to
We lost you again. I don't know. Maybe it's my problem or I don't know.
b plus a. It's not getting. You can't.
Yeah. We can't get you. Like we can't hear you completely.
Okay, can you hear me now?
Yes, I can. I can hear you.
Okay. So y is equal to b plus ax.
Hmm?
Is it the same as y is equal to mx plus c that Excel gives?
Yes. Yes, it is.
Okay. So now then b is equal to
B is equal to C there.
summation sxy sx.
No. In your thing, B is a coefficient.
Correct. But then in that your B introduction to biostat, that
So
weekly lectures,
yeah.
B was denoted as Sxy upon Sx square, right? B, meaning if y is equal to B plus Ax, then B was denoted as Sxy upon Sx square, right? Or not really? I'm getting confused there and probably I'm getting wrong.
No, it's not that. It's not that.
Okay, tell me, how do you find out if y is equal to b plus a?
Hmm?
How do you find out b and a? Just tell me that so I'll understand.
Okay. So that has to do with linear optimization. Okay. So so what in Excel, what it does is you have these data points, right? Okay. That's slightly more technical, but
But if you don't have to do Excel,
no, you can't do it. You have to.
if you don't
You
want
have
to
to.
do
No, you
Excel,
can't. You can't do it by hand.
correct.
Okay. Because what it does is
You can't do it by hand. Okay. That's the reason.
you can't do it by hand because you will have to.
But Professor
Yeah.
Sane, Dr. Sane, he was showing us something like that.
I mean, if you have all the, yes, you can. You can do it by hand. Yes, you can. I do.
And that's how the weekly assignment is.
Yes. You can do it by hand.
Weekly
And
assignment
I
is
don't remember
exactly
the
like that.
formulas, but it's something like that. 1 second. I'll tell you what those formulas are.
So he told that correlation coefficient is equal to summation xi by summation x square.
Yeah.
Exactly, yeah.
Yeah, but we cannot apply that directly.
Yeah.
Provided we have correlation with some value,
So in
we
your
can apply that. Find the b value.
So in your equation, that is b naught plus ax, no? A is nothing but y bar minus beta 1 into x bar, where your beta, sorry, I'll write it in this manner. Your b
Please
plus,
write, yeah.
yeah, yeah.
Because
I'll
I'll
just,
write it down then.
yeah, yeah. I'll just write this down here. So suppose your linear after, suppose your model is uh, y, your y is b plus ax, okay? Then
Correct.
your a is given by sxy divided by sxx, okay? This is what it is,
Correct. Sx square.
okay?
And Sx square is the.
Variance.
What is Sx square? It's the
Sum of
summation of
variance
the
square.
x square.
Sum of variances. Sum of your, so x minus x bar the whole square, sum of that. So it's sxx is nothing but
Okay.
summation. I'll just write this down.
So if correlation coefficient value is given, how can you calculate A value from this formula, sir?
I'll do it. Summation. Okay. Oh, sorry, it shouldn't have come here. Summation of x minus xi squared, okay? Squared, okay?
Correct.
Okay, that is your sxx, and xxy is what we did there, okay?
Okay. So here you don't divide by. It is not SD.
No, no, no,
It
no.
is not
Just,
a
it's just
standard
sum of
deviation.
squares.
It is
No, no.
something.
It's just
That's
sum
where I
of
went
squares.
wrong. Okay. Okay.
Okay. And
So
there is
from this, I
another
have one more
question.
doubt, sir.
Yeah.
Sir, if a correlation coefficient P value is given, rho value is given, how can you calculate A value using this formula, sir?
Okay. So your r square, so correlation coefficient squared. Suppose your rho is r, okay? R
Correct.
Yes, sir.
squared. So it's square, okay? Now I'm doing this. Watch this carefully. R square is given by sum of your residual square divided by s xy, okay? Where your SSR is nothing but uh, nothing but your summation y I minus y hat or y predicted. So when you draw a line, no, yeah, when you draw, for example, a line that is like this, you get,
Is it yi minus y predicted whole square?
yes, okay.
Okay.
So when you draw a line like this, these are your actual yi values, the points. Your y predicted lie on this line, okay. For example, if I zoom in, this is your y actual value, this dot here, and your y predicted is on this line. When you do y I minus y I predicted for that ith value and square it, and then you add all of those, you get something known as SSR. That is your sum of residual squared. Okay.
Okay.
Now, uh, sorry. Now, when you, one second, where is this? When you calculate your sum of residual square divided by sum of xy, this you can calculate, right? When you do both, you get r square, and then you have to take the square root of that. That will give you correlation coefficient. Okay. Now this is only true when your y predicted comes from a linear prediction. That is, you have done a straight line prediction. Okay. It's not true when you do something else. Okay. Only when you do a linear regression, this comes out to be true. Your r squared, the square root of your r squared value is your correlation coefficient. Okay. Did everyone get this?
Yeah, yeah.
So,
No.
so go into your notes and look at all these formulae. You'll get them online as well, and you'll be able to do it. So, you need to take the square root of this to get your correlation coefficient. And you can do that only when your linear regression, when your regression is linear. Otherwise, you can't do that. Okay, if it's polynomial or something, you can't do that.
Okay.
And another way, a simpler way to calculate correlation coefficient, we did this in the previous class, is it's covariance of AB divided by, if you have all these Sx, so sigma A, sigma B, and like that, you can calculate covariance between them, and then just plug in your values in this formula.
So tell me, this correlation coefficient is equal to covariance AB is given in the notes because. Uh, 1 minute, I'll just write it down.
Covariance of AB, no, all these slides are there, ma'am.
I'll check it out. Yeah.
Yeah,
Right.
yeah. And covariance formula also I've given, which is this covariance between A and B, or
Yeah.
X and Y, or X and Y. Okay.
Okay.
X, where X and Y are random variable. Actually, I should not write it this way because here I've written X is also the mean, but maybe I'll write X, small x and small y. Okay.
So I have one more doubt, sir.
Yeah.
So they were given in the assignment the number of cells in a culture increases in a continuous exponential growth. They are given two tabular columns, one in time and other in absorbance. They are at 600 nanometer. They are asking which equation best fits the data.
Have they given equations?
And they are given values, X value and Y value. And they are asking to predict which answer fits the exact data. They are asking R square.
So go to your Excel. Okay. Plot
Yes,
your
sir.
data. First thing. Okay. Make your X and Y values, plot your data, and then add a trend line and see which trend line gives you the best R squared value. Okay. R squared closer to 1 means your data is exactly matching your predicted values. For example, in our thing here, our line is very close to this data points. You can see R square is 0.99, which means our model is predicting the data very well. So go to your Excel thing. So all statistics, I'll tell you, the first thing to do when you do statistics is plot your data. Okay. And then Excel, and there are a lot of software which help you plot your models. Okay. And then get the goal of modeling, which is not part of this course, is to get as high your R square value as possible, as close to 1 as possible. Okay. It's not part of this course, but they've already given you a hint in the question. It's exponential. So you need to plot an exponential trend line. But if you plot the data, you'll automatically know that you have to do an exponential plot, exponential trend line. So go plot your data. Okay.
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 Always plot your data.
Without
Plot your
using
X and Y
Excel.
values and see how what kind of model is fitting in. Okay.
Okay.
Anything else?
No, thank you.
Okay. Okay. If there's nothing else, we'll end the thing. I will post these post the lecture, okay, on your relevant links. Okay.
Sure.
Thank you everyone, and see you all next week. Do practice permutation and combination. You need a feel for it. It's not easy, but the more you do, the better you get. Okay? And these are permutation and combination is very much required for you to know your sample space in your probability. Okay? Your entire sample space. Okay. Okay. Also look up Bernoulli's probability because we did a question of heads and tails, that is relative Bernoulli trials and things like that, and where your permutation combination comes to good use. Okay, do that. Okay, thank you everyone, and see you all next week, Tuesday, hopefully. Bye.